Hi, Tudor. So just to explain, I didn't have time to explain this properly, but as organizer, I'm just happy that I am able to at least speak one or two talks for things that I like, and I really like talking to Tudor. I think what Tudor has on his hands is something out of this world, and also chose to let's be aware of this kind of work he's doing with open source. And I discovered him through Twitter. Was kind of completely random, but discovering him through Twitter, we got in touch, and he gave me some classes about how to deal with legacy code, and I liked it so much that I found more CTOs should know about it. So with you guys on stage right now, Tudor, I'm inviting you to the stage. And check if you got the invite, and let's just double check if the screen sharing is working, because for some people it did not work. Oh, okay. Hi.
Hello.
Hi. I listened
Looks
to
like
you
it works.
perfectly.
Does it work?
It is working.
So far?
Can you see the screen sharing button on the middle button, the button on the right side? Okay, perfect. So, Tudor, the stage is all yours. I'm here without my camera. If someone needs to ask something, let me say this in português. Se alguém quiser perguntar algo em português no chat, eu traduzo, tá bom? Eu vou estar por aqui. And I'll be translating any questions on the chat from Portuguese to English if needed, okay? Thank you very much. And just for you to know, this is being recorded, and we'll be sharing this after the event with more people.
Okay, hello everyone. My name is Tudor Gurba, and today I will talk about moldable development. I am the CEO of Think. Think is a company that is focused on making the inside of software systems explainable. We think that this is the single largest problem in software engineering, and we are contributing to this end both new kinds of techniques and new tools that you will see live today. We fund ourselves we fund ourselves through consulting, and during our projects, we essentially tackle difficult or projects that are deemed sometimes impossible, that are somewhat odd, and they work both with legacy systems, or they might include both legacy systems or new systems. And I'll try to give a hint to you as to how we think about software development that allows us to tackle these types of problems somewhat differently. So moldable development is a new kind of technique. It's a new way of approaching programming that starts from this little idea that everything in software is contextual. So software is the most contextual thing that we've ever created as human species, and as a consequence, we can't really predict the specific problems people will have. Yet, people spend most of their time figuring systems out, and that's what we think we should be optimizing in software engineering, and not necessarily the construction side. But rather than talk about it, I would like to show it to you. So here I have a little, you can think of it as a notebook, where I have a short script here. Essentially, it's a path to so it's a file path to a folder on my disk, and I pass to it as file reference. The kind of code that you're seeing here is called, this is Smalltalk, and the specific runtime here is called Pharo. And if I'm now executing this object, this code over here, I get an object. So here I have a file reference. And this file reference points to this folder, and because it points to a folder, I basically see the contents of that folder. So I can see that there are subfolders over here. I can see that there are files over here. Now, this thing here that you see on the right, this is a little inspector. It's like an object inspector. So you're actually inside the development environment here, and it's like, setting a breakpoint somewhere, getting a debugger, and then you're inspecting something in that debugger, or you're in a REPL, you're inspecting the result of an execution, and yeah, you basically get an object and get an inspector there. Now, of course, by default, typically inspectors show you these kinds of views. So they show you variables and values. But we think that there's no single perspective through which you can look at anything in software, because that software is data, and data doesn't have a shape. Yet we as humans, to reason about anything, we need a concrete shape that we can perceive. And so, but like with anything in data, because it doesn't have a shape, the way we choose the shape can actually influence the way we reason about the problem that we had in front of us. And here we made the inspector essentially be able to accommodate different kinds of views. So here, for example, I can see, okay, here's the path through to this folder. Maybe I can click on those if I want to spawn further another one. But let's take a look at these items. So here, for example, I can see, okay, there are some files, and maybe I can pick one of those files. So this is now a package.json. Now, package.json is like a reasonably easy to understand data structure. Is a JSON, right? And we can see, for example, here there are dependencies defined. You can see versions here, and there are dependencies here. So let's simulate a very simple problem. That problem would be, let's actually go and reason a little bit about these dependencies here. And we can see, okay, look, these ones are actually, I see here lots of React Native. And indeed, this application that I am inspecting here, the source of which I'm inspecting, is a React Native application. So given that now that I know that it's based on React Native, then maybe I just want to understand the dependencies that do not go to React Native. Just a simple question. But notice how if I look at them here, like it's like not so easy to say, okay, I would have to take a look at this one. I would like to have to look at this one and this one. And notice how I'm actually reading at this point, right? Oh, no, this one not. And it's kind of hard to keep track of things. But there's another way to look at this. So rather than me using my eyes to read, right, there's a data mining tool. Why not use the tools as the data mining tools? So basically here, I'm going to open a little object playground, so like a notebook that is specific to this object. And if I'm saying here self, this self is going to point to this file reference. And if I say contents of this one, I actually can get back from the file the string. And now that I have the string back, I'm going to say, well, okay, let's actually use a JSON parser and parse this string. And if I parse that string, what do I get? Ooh, I get a dictionary. Great. So this dictionary has keys here. I can see, oh, look, there's dependencies, and there's a value here with dictionaries, which means basically that I can actually go there and say, well, at dependencies. So because Smalltalk is a highly dynamic language, I can actually use it to query the objects that I have live. And so here I have the dependencies. I get the dictionary. Great. And maybe from here, I will just get I don't like to have dictionaries because now I have to select those. So I'm going to just take the key value pair. So I just transformed it into an array of key values. And then, of course, because now I have an array, I can go and select only those for which the key begins with React Native, for example. Right? And this gives me the dependencies to React Native. And of course, if I reject those, then all of a sudden I have these 19 items. And so these are the dependencies that do not go to React Native. So what did we do here? What we've done here was we started from some, browsing the file system over here. And then we got into an editor, and then we started querying that thing because we don't want to use our eyes as a data mining tool. And then we basically created a little query here that was very, very specific to the question we had. So we kind of built a really custom little tool that afterwards allowed us to basically answer the question that we had. And so that's the essence of multiple development. We think that all development problems have a little tiny data science problem inside of them, and all of these problems should be tackled in this way. And this flow is pretty much the flow that we use to decompose pretty much all development problems we are facing. So let's take it a step further. So what else can we do here? Well, so I said that I have here a React Native application. Now, React Native is a reasonably popular language. So if it's based on JavaScript, as you probably know. And, if I take one of these JavaScript files, then all of a sudden I get here a file reference. But because this is now a file, right, I'm presented with code, and the code has highlighting, just like you would expect from an editor of a specific JavaScript file. But sometimes you just want to go and, for example, write some sort of JavaScript lint rules or search for some patterns inside the code. And the question is, how do you do that? Well, kind of in the same way. So here we have a string, but this is not just a random string, right? It's not just plain text. We know exactly what kind of grammar is in there, so which means that we can build tools, or we can use tools that understand exactly that structure. So a simple thing that I could do here would be to do exactly like I've done before. I take this object playground on a file reference, so self will point to this file reference. I'll have contents here, but in this case, because I know that now this is JavaScript, I'll take a JavaScript parser and I'll be parsing these contents. And as I'm parsing these contents, I basically get an abstract syntax tree. And now this abstract syntax tree, what's interesting, I see it here, I see the preview. Let's maximize that. I see the preview on the left-hand side of the code. And then I see the abstract syntax tree on the right. So I don't have to, understanding how the abstract syntax tree of the language that you're playing with, there's no magic there. It just appears to be magic because it's all hidden by these tools that most people are using. And that's another problem. The tools that you use define or determine to a great extent the kinds of problems or the way you will decompose the problems that you will find, that you will meet. And so you can also turn it the other way around. You say, well, in order for me to empower myself, I should be very careful with the kinds of tools that I expose myself to on a daily basis. And this is why, because software is so contextual, right? I just went now from just looking with something with JSON, and all of a sudden I'm now inside an AST of a programming of a piece of code. But I didn't really switch tools, right? It's basically pretty much the same kind of interaction. It's just something changed, the context changed, but the interaction is kind of the same, which kind of tends to hint to this idea that there is a systematic way in which we can decompose, the most common activities of understanding a software system in a way that makes it not only highly efficient, but enormously pleasurable. But let's go a step further here. So I was saying, that React Native is reasonably, it's reasonably popular, and you would expect this to be highly tooled up. So we played with the React Native application not so long ago, and within a couple of weeks, we ended up to this problem that tends to actually happen quite often, which is the cyclic dependencies between the components. Right? So in React Native, it's not actually JavaScript. It's basically its own language. And if you don't understand that language, well, if you're looking at the React Native code through a JavaScript lens, you basically are not seeing anything because most all semantics are in the framework. So you have to go and understand that framework, and only then you will understand, be able to reason about the code that you're seeing here. And that's another point here. Like software is never what it seems to be because there are always layers of abstractions in it. And if your tools don't adapt to those interesting layers of abstractions, you're basically pretty much blind. And at the end of the day, you're just left to piece together the overview by manually, which is highly unpleasant. So instead of that, well, let's actually build a model out of this. So we are actually, we parse it a little bit, and when you parse a string, you get a tree, like the inside of it, just how that string is structured. But then, that string can be maybe a JSON, maybe it can be an abstract syntax tree, maybe it can be an XML. But you get a lot of trees, and that's actually it's not a difficult problem. It's kind of a simple problem. And then the next thing you do after you have the tree, you're going to build a model, a graph model, with entities. You're going to resolve different references. You kind of can build a picture that you can reason about the not just in the individual tree, but you want to basically reason about the forest. So, for example, here, as I was saying, we got into this problem of cyclic dependencies between components, and then we said, well, okay, let's build a tool for that. We searched for a tool, and then there's no real tool for that, and that was surprising. But then it took a couple of days, and then we ended up with this, and we didn't have anything about JavaScript at the time. So then we spent a bit of time, and we ended up with this. So what you're seeing here, these are actually dependencies between React components. And now if I basically click here, it says, okay, render button has a dependency to button. So if I now look at the source code of it, indeed, I can see here that the render button, this one, actually has dependency to button, right? I can even click on the link, and it will tell me what the specific relationship there is. And then, for example, here, button has a relationship to formatted, to fonted text, which is here, and so on. So that's the that's actually another thing, right? So here we went from something that was simple, isolated, and now we've built a larger picture. But again, we didn't really switch the tools. So how would this work? Maybe in other kinds of contexts. Let me switch a bit and let's look at the Ruby on Rails. So here I have kind of the same thing. I'm inspecting the root of a Ruby on Rails application in here in the app. We have the sources, and as you know, in Ruby on Rails, or as you probably know, in Ruby on Rails, right? There's like it's Ruby, but like in React, right? It comes with lots of semantics that you have to understand in order to actually get the most, or to get the actual picture. One of the things that we have there is this concept of active records. Active records basically is like this magic object relationship mapping, in which if you take a look at this at active record, which is this magic superclass, and you take a look at the subclasses here. So this is a diagram showing me the hierarchy of active record, and so I can see these are basically the entities that are being persisted in the database through the main mechanism of Rails. And then, for example, I can take any of these ones, because this is not a picture, right? It is something that this is a living object here. And if I click on that, I basically find myself inspecting this class, and this class knows how to present itself. That's just like any other object knows how to present itself, and it's hosted in this inspector that is welcoming all of these different perspectives. And all of a sudden now I find myself having a hierarchy tree here plus an editor on the right-hand side. Well, what's interesting about this, right, is that this is a source code. This is the source code that comes from the Ruby, right? You can see here, this is the class called edition, and the superclass is application record. And all of a sudden but then there is another thing, because this class is actually paired with a definition of a table, which is called editions. So there's an extra S here. And then in this table, we're going to define all of these attributes over here. And so what we want to do, we want that when we actually look at this Ruby class and we look at these attributes, we want to see both those variables defined locally and all the variables defined in the database. And what's more, because in the database we have actual, like for example here, if I have this is going to be called a document ID. If I look at the source code somewhere here, we're going to have, for example, publication type ID. Then if I look in the attributes somewhere, hopefully, or not, no, not that. Well, there are some IDs that if we can resolve them, where are those? There's somewhere. I don't find one here. Okay, there's document ID. That's for sure. I saw that one. Okay, here's document. We could resolve that one with the sources we had. And so if we have this, we can also take a look at the direct connections, or we can tackle all the transitive connections. And so basically we know, okay, addition is made out of documents, which is made out and of role appointment, and an operation field, and role appointment is made of role. And so now, of course, now I can click on those and I can hit source code over here. And again, like the interesting thing here is that this one is paired. I have this view that basically connects these two different worlds, because now we don't just have a single language, we have two languages. We have Ruby and we have SQL, and boom, we can still make a model that actually brings them together. And that's another interesting thing, right? So we want to build system specific, or at least technology specific, but ideally system specific tools, so that that's the most effective way to extract information out of systems. Now, another interesting thing in Ruby is that, okay, you have the database, but then you have the inputs, and those are like these routes, right? So if I take a look at, I can also see here the Ruby routes, and then I see, okay, there are 668 of them. If I click on one of those, I basically see again, like I see the source code. This is where it is being defined. This is the definition, but this is where it's implemented. So this is how that thing is actually mapped onto the method that actually deals with it. So we have all of these, all this magic is actually, again, resolved. It can be resolved by the tool or by a tool. And then, of course, we can also take a look at path. I don't just have to look at, so the different path. And we always wanted to say, well, actually, why don't we see the API done in a way that I can, for example, see, okay, look, for this URL, I can do get, post, and get. So two kinds of gets and one post. Why is that not easily visible? So now we can do that. And of course, if you can click on one of those, you're going to see, okay, it's actually in this route. And then if you look into this, if you look into the routes, right, you can find the extra, the places in code which defines it. So the point that I wanted to say here is just this: like software is so complicated, like it has so many details that it's impossible from the outside to predict the specific problems that people will have about the systems. And because it's impossible, we have to turn the thing upside down. So because we cannot predict the specific problems people will have, it means that the tools have to be created after the problems exist. So if we look at a flow, I always start with some sort of a question. And for that question, I want to apply an analysis. And of course, if I interpret the results, and if I'm confident, I'm going to make a decision. If I'm not confident, I'm going to repeat this. And this is nothing new here. This is the scientific method. However, because in software, there isn't, because I can't predict the specific questions people will have here, I also don't know. I can't give you a clicking tool. And because I can't give you a clicking tool, you should always ask yourself, is the tool that I have in front of me, or are the tools that I have in front of me the appropriate tools? And if I don't have the appropriate tools, you should take the time and mold some tools. And that is the essence of moldable development. Now, in order to make this practical, we want to make this so practical that you end up doing it for every single problem by every single developer. Now that's a reasonably difficult, it's an interesting challenge at least. But in order for it to at least meet the economic, for it to be possibly economically viable, the cost of creating these kinds of tools must be really, really low. And that's basically what we do with Glamorous Toolkit. So the environment that you're actually seeing in front of you here is called Glamorous Toolkit. It is an open source project. It's something we call a moldable development environment. It's a new kind of an environment that marries multiple different perspectives at the same time. But the key aspect of it is that we want to empower people to create custom narratives with and about software systems very, very quickly, and use those narratives as a means to both understand and communicate and to make decisions about a software system. And this we played with some sort of static analysis, but let's apply the same kind of principle to some other domains. So here, for example, I'm going to have, if I go to this URL over here, which is the API, the GitHub API, and I'm going to look at orgs FinCom, that's our organization on GitHub. And if I look at that one, if I basically used here an HTTP request to this URL, I essentially get this string with lots of JSON inside of it. And of course, like, what do I do when I see a string? Well, I always want to transform it into at least some sort of an abstract syntax tree. And exactly that's what I would be doing here. So I'm parsing this one exactly the same way I was doing with the package.json. And now I have here keys and values. So I can see, oh, look at that. Somewhere here, I see, okay, public repos. These are the public repos, but you also get these kinds of URL, like events URL, or where else do we see some other URL, public members URL, and all sorts of other URLs, which actually I get these kind of URLs that if I follow those, I will get another JSON. Now, here's the interesting thing. This whole dictionary over here actually begs for a name. Because like I just have this data structure, but it would be so interesting if we would give it a name. So here I'm actually giving it a name. I'm creating a new object of a type GH organization, so an organization object, and I'm just simply passing this dictionary into it. And when I do this, then I give the opportunity to this little object over here, which is like a kind of meta object, if you want, right? It's just it's a first class. If you think of it in domain-driven design, it's like a first class entity that I just have here. And now this object has views, like for example, it has views about repositories, right? So this little query, this little view over here already packaged the query and presents it to me in an interesting way. And what happens if I click on it? If I click on this, it does another query and it gets another object that knows how to present itself, right? So this is a repository with all the different events here. We can see we just released something in Glamorous Toolkit here. I can also see the contributors. For example, this one does some other queries, and sometimes it's not as fast. So, so here we see the different contributors, and I can, this is me, and now I can see, this is my avatar, this is my events, and I can see the kinds of things that I've done. And basically, the reason I'm so active is because my user is the default user that is being used every time people commit something. So, I'm the CEO, so people should make me feel good about, not wasting too much time. So, so if I look at this, I basically transform the inspector into a browser of an API. And so we're completely in a different place than when we just looked at static analysis. Now, in the same way, or another kind of problem, it also goes to if you can build these kinds of views about the inside of systems, because basically here you're literally looking at just objects. And if you can do that, you also have all sorts of interesting opportunities to, for example, document, but also to support onboarding. So here's, for example, a documentation of a little React Native snippet over here. But what's interesting about this one is that actually it has these kinds of links, right? So we can see what is being referred to here in the text. And the other interesting thing about it is that this is actually live. So if I have just removed that one or I add it back, then I can see how these links actually work together. So here we have a little very custom-made documentation page that just works with this kind of, it works with this type of the library is specifically made just for this one. So the context of a tool can be as small as we want it to be. We don't have, and because when you get the cost of these tools, when you get them to be really, really low, all of a sudden you don't have to go and plan for them. It should become a natural part of an integral part of the costs or the investments that engineers basically make on a daily basis. So, but we can actually go a step further. If you think about, now we were just into different places, right? So we were static analysis, then we looked into the API tools, and then we looked into some sort of documentation tools. And then there are all of these. The reason I'm just describing it like that is because that's how we typically think about this space, right? We think, okay, here's an IDE, these are notebooks, API tools are somewhere else, knowledge management is yet in a different place. And then we were kind of trained to think across these tool boundaries, right? For every one of these bubbles, we will be having our favorite tools, and then we'll find ourselves jumping from one bubble to another as the need happened during the day. But the problem here is that the premise is wrong, because these are not different spaces. They don't have to be different spaces. We can think about this one and invest in this whole tooling subject completely differently. And so that's exactly what we are aiming to do. We actually think of that this whole space needs to be decomposed completely differently from and not how it typically happens today. And we should not be waiting necessarily for tool vendors to provide us with whole full-fledged vertically integrated tools, but rather have the possibility to express and adapt it to the context, because that's actually the most important thing. So if we look at this one, let's say if I take a note over here, right, like the simplest use case we can possibly have would be, say, this is a note. I'm just going to take a note, right? And then maybe this is a sub idea, right? It's like what you would expect from a kind of a like a wiki thing. So we can also maybe say that this is a sub idea, and then say that we're gonna make it and italic, and notice how the markup appears and disappears. But maybe, okay, this is a link about, and I'm gonna put here something like moldable development, for example. And now if I do that, now I get this link to a page, and if I click on that page, I'm all of a sudden finding myself into this page, right? So I'm now actually creating these links like you would expect from a wiki, and then of course this one has backlinks from the different places where it was being linked. But I haven't left, right? This is not a separate tool. This is a single environment where all my thinking happens. And for example, yesterday, I think for people that were at the conference, you took a look at Wordly maps probably. So here you have a Wordly map. This is actually this whole engine here, this kind of the notebook system, is made of snippets. Every snippet can come with its own language. Some languages don't have to even be textual. Like, for example, this is a Wordly map that you can play with it. I can add nodes, I can remove nodes, or add them in a different way. And now what's also interesting here is that I actually have a link from this node here to some software assessment page. And if I go to that page, what will happen here is that I will see that in the backlinks here, there's a link that comes, for example, from here, from this page, and another link that comes from here, right? And notice how actually this is live. So we have like a knowledge base in which you can express knowledge in many different ways. And the most interesting thing is when you start to combine, these are statically defined. Even more interesting is when you start to combine these things with computation, because you can, this is a live environment, so you can do all sorts of interesting combinations. So, in fact, this whole thing here is part of a Glamorous of the Glamorous Toolkit book, which is the documentation that comes with the environment itself, and you can play with all sorts of different kinds of use cases here. I'll actually invite you to go and download it. It's, as I said, go to gtoolkit.com. It's free and open source. You can download and play with it. But we also we also are using the same kinds of tools for all sorts of kinds of technical things. So here, for example, I have a snippet which embeds a link to Jenkins. So we use Jenkins as our build system, and I have here my credentials, and I can actually go and browse that one. And if I basically go here, what happens here is that, again, like I've done in the case of GitHub, basically when I go through a repository over here, right, I do another query to another URL, and I get something. So, for example, here are the branches, and then it will give me all the runs. I can also directly go to these places. For example, failures are interesting to look at, and I can see, okay, these are actually all the steps. I can see, okay, this one failed in smoke test. Actually, don't know what the problem here is, but we can go and play with this. And if you're going into it, we would see here the different steps, and for every step we can see the console. And what's more, this console actually comes with syntax highlighting. So, and it highlights the kinds of things that are specific for my problem. So I can see, okay, look, this is the actual error. So this syntax highlighting is custom made for the kinds of problems that we are facing, right? This is not a public, this is not the same errors that anybody else will have with Jenkins. It's specifically for our system. And if we want to go and extend that one, we actually can, click on any of these views to find how it is implemented. I can take a look and then go and modify it from there, basically. So here, for example, I can take a look at the same console log, and I can see how it is implemented. I can even go here into the styler, because there's an editor there which gives me all the log, but then I have a styler on top of it. And if I look at that styler somewhere over here, there's going to be a style method, and this style method actually gives me all the different patterns that I have. And so now I can go here and then change the different patterns that I'm interested in, and I can actually do it live. So that's another use case, right? So the entry point is this notebook kind of thing, but then all of a sudden I can go into these inspectors with which I can combine and build all sorts of interesting views. And in fact, for Jenkins here, we actually put together 4 different APIs to consolidate a single experience. And this experience for us is much better than the experience that we get from the default Jenkins. So this is a new kind of an ability that you have, this ability of creating these custom tools. But there's another role. We call this the facilitator skill. But there's another role, the stakeholder role, that is as important, or probably even more important, than the ability of creating tools, because that's these 2 roles, they have to work together. So the one that builds tools does not necessarily understand or needs to understand why a specific question is important. So if that happens, is great, but that doesn't necessarily have to be the case. In fact, we actually find that if you have 2 different people playing the different roles at the same time, you get much more interesting results. But because they basically play at different meta levels, right? And you want to have both of these kinds of roles embedded into your. This is a technical role, and this is pretty much anybody that has any question about the system, going from the developer all the way to a manager, or maybe even an executive. And the goal of a stakeholder is to essentially reach a decision. That's always the goal, right? And so the facilitator plays a support role. This is not it's not like quality assurance. It's a support, much more like a dev and ops, for example. And so this facilitator is a cross-cutting role. It's a new kind of skill that we think that software development shops should invest in. And the question here is only, at the end of this presentation, is why is this even important? Okay, it can be shiny. We have all these tools, but why does it really matter? And the reason it matters is because if you think about development, right, most of the time we think about the active part of constructing a system. We think about the, like, I don't have it, I spent some effort, and I'm going to build a system that's going to do I don't know what in the world, and that's great, right? And it's amazing because, like, through our skills as developers, we got to affect pretty much everything in this world. But if you look closely at what developers do, they don't build systems for most of their time. They spend the largest sum of their time reading, usually, with the goal of trying to figure the system out so that they can make a decision. And we think that, but this time, if you think about it, right, you rarely see, if at all, if you rarely hear conversations about how people read code, for example, how people read or relate to the inside of their software systems. And we think that this is not really appropriate because 50% or more, which is usually what is being reported, and I myself talk with several thousand developers to and ask them, do you agree that you spend 50% of your time reading code? And they say yes. And then I say, well, do you talk about it? And they typically say no. I never really talk about, I talk a lot about the code that I read, but never about how I do the reading. And then if you think about it, right, it basically means that we're spending the single largest chunk of the budget that is being given to us on a single activity nobody talks about. If nobody talks about it, it's not explicit. If it's not explicit, it has never been optimized. And every time you're looking for optimizing the performance of a system, you're probably going to look for the single largest chunk of time, energy that is being spent on an activity that has never been optimized, because that's usually where the order of magnitude comes from. Thank you very much.
Thank you very much, man. That's really interesting. And I know some people are probably a little bit confused and you want to understand more, they want to ask a little bit more. If you guys want to ask, it would be nice if you can ask in the chat, but I do have some questions. Because in my opinion, and I'm saying this as a friend, but you should start with the why. Like, this why is what I think is the most important insight from it all. That is, developers shouldn't always be coding. We are not always coding, and we need to understand what do we do when we're not coding and why we're not building tools for the second moment. We think a lot about tools for coding, tools for integrations and so on, but the tools for knowledge in the team are really important. And David asked in the chat, how do you see the current states of existing tools and languages regarding how to capacity the people to capture the code intention? So when the next developer comes, they will evolve on an existing code. And I know some things you'll talk about it. So I want to complement this question with why we see legacy as something so bad. Because we don't understand the intention people had to do code, right? So how do you see the tools for this, and how do you see on how we can build better tools for capturing intention?
So first, well, thank you for the questions. And you started with this, like it would be great to start with the why, and I very much agree with that. But the thing is that we started this work 12 years ago, and we had 12 years of trying various kinds of discourses. And as much as we'd like to start with, conceptual things, it turns out that the audiences are very much trained to look for immediate details, things that might be applicable in their context, and that's why we have switched our narrative basically based on that feedback. We'll see if this one works better. But the other thing here is that I've only scratched the surface here. It's the surface. It's very easy to think of tools as a set of features, and then we'll ask, well, what kind of features are in this tool or in whatever tool? And we've been trained to think of those. We are actually comparing features, and it actually got me to think. I remember once when I was buying a phone, right? And in summer 2006 or so, and so right before the iPhone, and there were at the time I just realized, well, actually I only used four features of a phone at the time. I was only making a phone, receiving a phone, only receiving text messages because I was never able to write one, and the alarm clock. So that was basically it. I just needed four things from that tool, and then I went into a shop, and I distinctly remember there were just all of these phones. They were listed, they were displayed on the wall, and they were the descriptions and the different features that were aligned below the tool. And there was like these two Nokia phones. Oh, and or the Samsung phones, and you'd have these two different versions, and then they would start exactly the same way, and then one of them, the old version, would stop here, and then the other one would continue going, right? And this is how you would know, okay, this does more, right? So it's probably better. But of course, if you're only using it for some parts of it, then it doesn't really matter. But now, the reason, right, we kind of tend to do the same thing with the tools we have here. But if you think about it, when the iPhone came and all these phones that we are typically using today, they no longer come with specific features. They come with a platform that allows you to quickly customize the experience such that it fits you. And so you'll find yourself having lots and lots of little apps, right? And of course, like those apps are actually broken as well, because we have to break those things into little pieces as well. But if you compare the older situation with the new situation is much more moldable. It's much more malleable, basically, and adaptable to a context. Now, the difference that we're seeing here, we think that we have to push this one to the whole extreme. And we have started basically this whole environment by rethinking, how do I deal with a single object? And it was interesting to hear. So, like, you have this question, right, that David asked, which is, how do I ensure, like, how do I capture the intent such that when somebody else comes in, they have a boost, right? They don't have to start from scratch again and figure, what were you thinking? So I actually have a few other demos here. So one of them is this one. So it's another way of applying the same environment, but in this case, we actually applied it to documenting an understanding of a domain-driven design. So this is like a restaurant over here with a cozy corner, a guest room, and a kitchen, and a table 1 and table 2. And at the tables, I have a waiter and a guest, and I have a cook over here. And this is not a toy. This is actually a real system. And this here, we see a little algorithm. And the algorithm is, how should these different actors in a restaurant communicate such that they don't necessarily need to know about each other? I'm not going to go into those details, but what's interesting here is, again, like, I'm in a document over here, and it kind of figures it out, right? And I can see, okay, look, Alice guests opened the phone, connected to table 1, placed an order, and this order went all the way to the cook. And now the cook has an item on the to-do, and if I click on this, and I can figure out what's happening next. Now, there are actual objects that are happening here. This is a real runtime system, and I can actually take a look at that. Right, this is the understanding of the domain. And what is even more interesting is that we are actually using these things to actually talk with business. And we can, for example, think of domain-driven design. People talk about this ubiquitous language, which is like a great idea. But usually this ubiquitous language lives only on a whiteboard. And the whiteboard is great for thinking about the future system, but it's terrible to think about. It's a terrible tool to use against the existing system, because every time somebody draws something about the existing system manually on anything, it can be even in a CAD tool or so, what you're drawing there is the belief, like the author's belief about what the system is. And that's the problem. Decisions should never be made on beliefs. Those drawings are great when they describe the future, they describe wishes, but we should never be using those kinds of drawings to reason about the existing system. Instead, we should make the system capture every one of these pictures that we are typically drawing on a whiteboard before we start building, and or while we start building. And then we make it the job of the system to carry these views forward. And once we carry those systems, once the system can present us with all of these, can be thousands of views. And you can also start combining them with all sorts of interesting narratives that are interestingly useful or interesting for different kinds of stakeholders. So, for example, pictures like that can be, or we're using also to help companies pitch to investors. It can go so far that we are giving executable pitches to investors from inside a development environment. And this is way before there's any application, because you don't have to wait until you have everything and only look at the system from the outside. You can actually look at the system from the inside, and you can create value just by doing that. So Does this answer the question?
It does answer my question really, really well and beyond. And actually, what I really like about it is this what drove me to learn more about all of this is it is possible to give tools because when I'm talking, I am on a startup. When I talk to the CEO, he only knows how the code works because he believes on what I tell him. If I tell him, oh, the code's not working because of Kubernetes, he's going to believe me. But on this one, I can give the skill of understanding code to non-technical people. And that's really interesting because you don't need to build an MVP to prove that you can link to databases. You can just show the databases, show them why they are linked or not, or how they can link or not. For example, just one silly example. And that's what I find really interesting here because it is. I don't know if people are getting this, but you're not using PowerPoint. You're using Glamorous Toolkit right now. This presentation is made on Glamorous Toolkit, right?
So it's actually part of my personal knowledge base, and I'm just presenting it from here. And this is basically the environment that you're seeing here. So yeah, that's what is being seen here.
Yeah, and that's really powerful. That's really interesting. And David has one more question. David, if you want to come to stage and ask personally for him as well, it is open if you're open to that. So I'm going to invite you if you want. If you don't want, it's fine as well. But what he did ask you, how do you testability of this kind of system in different scenarios inputs? Oh, he's here. If he wants to elaborate.
Sure, that's basically the question. But I was wondering how to get this graphical system, which, well, by the way, great content and great presentation. But how do you get this engine, this algorithm, and you test? I mean, we have TDD and this kind of automated tests. How do you test the algorithm and check the output? How would you do that on this kind of system? I'm just really curious.
So this here is actually produced by a test. So here it's, you see, a test, if you think about the test, is usually I set up something, I do something. So here I create my cozy corner, I create an order, I create a place order message, and then I'm telling Alice guest send this place order to table 1, right? That's the thing that I want to test. And then I have these assertions, right? So this up to here is like a test, right? But that's the thing. All testing frameworks stop exactly there. But now, because we have an environment where we can have very, very interesting conversations with objects. And by the way, we can also work with objects that are coming from other runtimes. So, for example, we have out-of-the-box bindings to JavaScript and Python, and we can do similar things to those. Maybe not exactly as advanced at this point in time, but those will come. So this is not specific to this. It's just that this is the place we started from. But all testing frameworks start exactly here, right? All testing methods, right? They or functions. They are void functions. They don't return anything. And that's such a terrible waste because now I went to all of this trouble to creating this beautiful message that I'm going to place, from Alice guest at table 1. And then I'm asserting that it has these interesting properties. Now I know this is a very interesting object. So why waste it? Why not return it? So what you're seeing here is actually a return. So if I execute this one, by the way, this is a static editor over here, but because this is a contextual thing, even the editor starts presenting me with different things depending on how I'm annotating things. So here I just executed this example, and this example gives me what? An object, an object, which if I inspect, gives me a view that gives me this kind of interaction. So it's exactly the same interaction that I see in the documentation. And so in this documentation, I did nothing else but simply point to the exact to this example. So we've also addressed this little problem of how do you make documentation be in sync with the code? The solution there is that never move the code anywhere. We just point to it, and so all documentation is by default testable, like all execution parts, because we are only embedded those kinds of things that have been tested before. And this, by the way, this offers a whole new whole new way of doing domain-driven design, where you literally speak with every one of these examples. Actually, we also have, because these examples are just pretty simple methods, you can start composing those methods. So for example, this example here, depending on a larger example, that just set up the, if I execute that one, it just sets up the restaurant without sending this message, right? And this one was based on some other thing that did some other more fascinating things in there. So I can have this. The reason why this is interesting is that every one of these examples can simply become the context. It can document all conversations I have with my, for example, business or domain experts. And next time we meet, we can simply say, "Oh, let's start from that scenario and build on top of it." It's just like a very natural. It's a very natural place and a way to have these types of conversations.
Perfect. Thanks so much.
Okay. So what I'm gonna do is, I think we are reaching our time. We have just 4 minutes more. What I'm gonna do is, Tudor, what would be the best way to make this conversation keep going? Because I know some people are curious and they will probably maybe try downloading the JToolkit. What do you recommend to us? What we could do next to maybe start a movement here, a small Brazilian testing community of this idea or something else?
Yeah.
What do you think would be nice?
Okay, so there are a couple of practical things. So the reason we're building, so we are a commercial, like a weird setup, because on the one hand, we are a commercial entity. We have this tool that allows us to basically tackle strange problems or difficult problems and have a significant competitive advantage, but we're making it freely available. We're documenting as much as we can as well. And because the reason we're doing all of that is we want to educate. That's our goal. And we also, want to build a community. And so if you go to jtoolkit.com, there's a link to Discord right there, which that's an entry point. But any other let's take just an initial starting point. But this thing will work if people will take it and making their own. It would be awesome if people would, want to spend some time to look at that, explore it, and we'd be happy to support. We also have conversations via Twitter, so feel free to reach us there. So at GIRBA, that's me. At ThinkCom, that's our group, our company. So jtoolkit.com, that's the main page of the environment. But if you're looking for doing something, start from meet Glamorous Toolkit. We built Glamorous Toolkit because there's such a large conversations to be had here. But it was not visible. If you're just talking about it, it's just not. You have to see, you have to practice, you have to feel it. If you're not there with the actual problem, and try to see how these kinds of tools would address those problems, it's pretty much impossible to grasp and to understand. So, but if there is one thing, if you could just do one thing, and it has nothing to do with the tools, and it has nothing to do with what we do, is just start talking about how you read code. And spend, 15 minutes per day talking with everybody around you about that. And what you will find out is that you will, because nobody talks about that, it's just not a subject of conversation. So if you think about, for example, what happened in the DevOps space, what happens in the DevOps space today was probably unpredictable 12 years ago, when the conversations were not started yet, the global conversation. But once we started, all sorts of new patterns agreed. What we want to do is we want you to start that conversation. We give you a very, very concrete technology to start from. But don't rush to conclusions, because we have spent 12 years actually doing deep research. There's a whole lot of research behind this. And don't just copy 10% of it. If you want to copy it, copy the whole of it. Or just go ahead and use that one. But really, start from just this. Start from asking, and this is a group of CDOs here. So start from asking, how are you spending the single largest chunk of your budget?
Yeah. Start asking how you're spending most of your budget. And right now, I know it varies a lot, but I see a lot of people spending a lot of time doing. Yeah, you're sending the links, okay, and doing just whatever they can, right? Like spending on legacy code, on proving things, and so on. I think this question you just asked, it could be an entire talk. What are you spending most of your budget on? So that's really cool. And I'm gonna then end here because we're out of time. I'm gonna give lunch time for people this time. I did not do this yesterday and did not go well. And so I'm gonna thank you very, very much, Tutor. You just sent all your content over there. We will share this through the email after the event. And yeah, I think that's it then. Do you have like any finishing words?
No, I'm
Okay.
I just wish you all of you good luck.
Thank you very much. And thank you everyone that finished listening to the talk. We will be back in 2 hours with a roundtable about data. See you soon. Bye-bye.